So again, that page 2 of your notes, have you turned that in? Have you turned in your work with your mates? Every group can have a point for hearing me ramble. Again, I really don't think second period is the root of my issues, but for second period, since you are with all the others, and I'm not going to special treat you, that's not very fair. So,
It couldn't have been me.
well, first says it's y'all, you know, of course they do, and then third's going to say it first, and everybody's going to blame everybody else. So you know what? Everybody can just have a 0 for the mates until they show me they did work. Okay. Today is the day. The day. We're going to combine our graphing skills and our factoring skills and use them both at once. So if you struggled on the last test, you've got to get it together and get it together quickly. We're taking a test on this on Friday. We're going to go over how to deal with the zeros today, tomorrow, Wednesday. Review Thursday, test Friday. But first of all, we still got to be able to factor. So help me with our math word solves. What do I do on number 1? No, take away. Thank you, Jax. You can have your point. And I'm left with, thank you. Perfect. We get to number 2. There are 4 terms. What am I supposed to do with 4? Grouping. Thank you. What do I pull out of that first group? What am I left with? What do I pull out of that second group? What am I left with? 4 and 5 get a point. Perfect. Let's move on to number 3. I need 2 things that add to -8 and multiply to 64. Why the silence? What's the deal? Give me some options of things that multiply to 64. 8 and 8. 1 and 64. What else? 2 and 32. It's 4 and 16, you said? Okay. Anything else? Because none of those have a difference of 8. What are we going to do? What are we punching in so frantically? Like, what are we going to do? Okay, so Ellie said, wasn't it you, Ellie? And she can have her point. But I'm going to need some proof. How can I prove this is not factorable? What can I do? Hit, I'm giving it back to you today. What could I do using this to prove to myself that's not factorable? I am going to graph it. Yeah, so you can have your point. And you were on the wavelength no one needed. I'm going to graph it. Okay, so x squared, because I don't have h's, I'm just going to change them to x's. X squared minus 8x plus 60. Oh, I'm up at the top. No. Minus 8x plus 64. And I press graph. Huh? Welcome to regular. That's it. I'm going to ask that question right now. Okay. I pressed graph. I typed in this. I pressed graph. It didn't show up. What's the deal? Okay, so I thought Zoom, and I changed it to Zoom Fit because since Zoom Standard was letting me down. So, I mean, it does exist. And Zoom Fit is deceiving, because on Zoom Fit it sure does look like it gets close to that x-axis, doesn't it? But maybe I should go back and not question Zoom Standard. Is it possible maybe my parabola is just up here and it's just not showing on this 10 by 10? Okay, so that means that it's not crossing the x-axis. So what does that mean about my two zeros? What are they then? Thank you. If you said imaginary, give yourself a point. It's got two imaginary roots, zeros, whatever you want to put. Yep, that's going to be a thing we're going to need today. And then number 4 is my favorite. My gosh, you're on fire today. You can have another point. He did the difference of two perfect squares. And while I'm super happy he did that here, and I really can't remember Jackson's test, so he may not be the one I'm picking on, but I'll pretend it's him anyway because he doesn't care. I had quite a few on the test who did this. Again, that's the difference of perfect cubes. We were supposed to factor. Remember we had this whole SOAP acronym, like we were supposed to factor. And yet I had a lot of people who just set that equal to 0, set x cubed equals 64, so x equals 8, and they called it a day. We didn't do any problems like that. We factored every single time. So on 5 and 8, if you know you made that mistake and you want to come see me later and fix that before I for real finish grading this bad boy, that would be a great, terrific idea. Because we were supposed to factor. Because yes, you found the real root, but we were also supposed to be able to have this quadratic left over so we knew about those imaginary roots. And whoever's paper this is, all they have is the one real root. I still need acknowledgement of those two imaginary roots. Okay, moving on from that, let's get out your notes. We already dealt with this. So last week we were talking about how to graph stuff in our head, like it's a fourth, it's a W, or an M, depending on that leading coefficient. If it's a cube, it's a snake. Like we spent a lot of time on how to graph in our head. And then we spent time on factoring, weirdo factoring, but it's supposed to be helpful, supposedly. And then on Friday, you had to watch a video of me doing synthetic substitution, which, if you zone out on that, it's super easy. If they ask for f at 4, yeah, everywhere you see an x, you could put in a 4. I'm not saying you can't still solve it that way. You can, but it actually might be faster to use synthetic division. Because if you use synthetic division, whatever remainder you get is the same answer you would have gotten if you had actually plugged in a 4 everywhere. So it might be a little faster. So that was the point in synthetic substitution. And I think you got it because, again, I know most of you have completed the maze, but sad day, I'm going to need work for that maze. So we can correct that 0 you currently have because somebody is dumb. Okay, we're going to skip the bottom 6 because we got life to move on to. Long story short, they're cheating. They're telling you one of the zeros and asking you to find the others. And that's great, but we're about to live in a world where they don't tell us any of the zeros. So why even mislead us? Let's go straight to the world of, I don't know any of the zeros, let's find them. Now, pre-AP algebra 2 trig spends a lot of time on this page with this rational root theorem. And while it's terrific, I'm not going to lie to you, it is a pain in the rear, and I don't really think it's time-saving. So we're going to talk about it, but in regular, again, now we got that graphing calculator back, we're going to cheat and use that graphing calculator to figure out some of these zeros first. This theorem's great, but, Okay, so this theorem says we need to know all the factors of the number with no variable. So all the factors of 12. So 1, what else goes into 24? Sorry, 24. What else goes into 24 besides 1 and 24? 2 and what? 2 and 12. What else? 6 and 4. Do I have a complete list now, we think? It looks good. Okay, and so this one we call the Q. And then the number in front of our leading coefficient, which is a 1 in this one, so it's a plus or minus 1, we call our P. And if we consider all of our p's over q's, we have considered all of our potential roots. So for instance, positive 1 over 1, 1 over 2, 1 over 4, 1 over 3, 1 over 6, 1 over 8, 1 over 12, 1 over 24. Those are all potential answers. We could, use synthetic substitution or synthetic division or whatever and test them out and see. But heck, then we could go back and do the same with all the negatives. Negative 1 over 1, negative 1 over 2. You can see how this would be a giant pain in the rear. So it's supposed to be this theorem that was like monumental of here are all of your options, plug them in. But who wants to plug in that many options? Nobody. So while that theorem's great, and maybe one day you'll hear it referenced again, we don't need it. We're going to, no. We got our graphing calculator. This is the 21st century. We're going to let that theorem go. So we're on number 1 on the next page. They want us to find all the zeros. And again, we're going to cheat by going straight to our graphing calculator. Our graphing calculator can help us figure this out. So you've got to press y equals. We've got to graph this. So x to the third plus x squared minus 17x plus 15, graph. Okay. Anyone have issues getting here? Well, some of what we tested on last week is useful now because I know my graph is right and I didn't mistype a button or whatever because it was a cube with a leading coefficient of 1. So it's supposed to be a snake up the wall. Hey, this is a snake. It goes off screen, but it's a snake that goes up the wall. So I'm happy. Okay, zeros happen where we cross the x-axis. I could guess some zeros right now. If I guessed my zeros, what would you guess? -5. 1 and your group gets a point. Now, while she's a great guesser, and for once her guessing is completely correct, it would be nice to confirm that guessing. So what could we press on the calculator to confirm that her guesses were correct? We normally press second, but is second what? I normally press second calc, and then the way we did min and max, you can do 0. We'll come back to using that later. For now, press clear. We're not going to do that today. We're going to be lazy today. We will second calc when it's a decimal one. But you and I are in a hurry, and I've been keeping this button from you for a while. It actually is useful at times, and that is the one that Tylen said, which is trace, which is why she gets a point. If you'll press trace, and so Angel guessed that 1 was an answer. So if you'll press 1 and then enter, I know Angel's right because it actually is a value of 0. My calculator says y equals 0 when x is 1. And that's what it's supposed to be. If y is 0, that means we're on the x-axis. Okay, so let's check our other stuff. She said 3. So I pressed trace and then 3 and then I pressed enter. She's right again because I've got y equals 0, so I know she's right on that one too. And then trace -5, she said. Make sure you do the tiny negative, not the giant minus sign. Again, she's right. So she can confirm, and not just be guessing, she can confirm those really are the zeros by using the trace button, or if she's super fancy, second calculate will help as well. But then, of course, second calculate, you got to set those bounds, and you know that's annoying. So we're going to save that for when we absolutely must use it. Okay, so let's go back to our problem. Angel has already solved it. And the answers are going to be -5, 1, and 3. Those are going to be our zeros. She's correct. And while that's going to work for this one, her strategy is not going to work for some of the others. Because what if we have imaginary roots? Or what if we have decimal ones, like 1.5 or 3.2? Like, what are we going to do then? So while this one's going to be awesome, and yes, you could have figured the whole thing out from your calculator, we are going to treat it just like a normal one. That way we know what to do in the next stage in life. Okay, so you and I found that 1 was one of the zeros. So I could have, when I knew 1 was an answer, I could have used synthetic division and said my leading coefficients are 1, 1, -17, 15. But, you know, this is going back to that first chapter 5 test. So if you messed up on synthetic division then, my goodness, now. 1 times 1 is 1. 1 plus 1 is 2. 2 times 1 is 2. Negative 15 times 1 is negative 15. Now, duh, I knew this was an answer, so of course I got a remainder of 0. I've royally messed up if I didn't get a 0 here, because I already knew it was an answer. Okay, so we figured this out. So it was a 3, so my next one starts out at a 2. So I've got x squared plus 2x minus 15. Do I have x plus 1 or do I have x minus 1? Thank you. You can have your point. Remember, it's the opposite side. Because this leads to this. Woo. And now the next question is, can Gilberto or whoever's trying, can we factor the x squared plus 2x minus 15 to what? Yes, and even if you weren't good at factoring, we already knew the answers. We already knew we were supposed to get a negative 5, so of course we needed a positive 5. We already knew we needed a positive 3, so of course it's a negative 3. Now he's right, and 5 minus 3 is 2, and 5 times negative 3 is negative 15. So yes, the boy can factor. But we already knew what the answers were supposed to be. So, yay. And then you're like, oh, Miss Compton. That was interesting. Oh, Miss Compton. If I already knew what the answers were, why am I doing all this work? And again, Cooper does not have to do all that if it's a nice one like this. But that's the only nice one we have today, because they're not really going to actually be nice. We've already dealt with all the nice ones in life. The reason you got your calculator back is because now we're in hard world. Not that I felt sorry for you, but now you need it. Okay, so let's go to 3 for now. Let's go ahead and graph it. So x to the 5th. Oh yeah, you remember that rule I promised you about it never be higher than degree 4? That's out the window now that you got your calculator. We can go as high as we want. X to the 5th minus 8x to the 3rd minus 9x. X. So I've got it. I graph it. I've got some guesses. I'm thinking it's what? Where do I think my zeros are? And then again, I should confirm that with Trace. So Trace, negative 3. Yes, she's right. Trace, 0. Yes. Trace, 3. Yes. So Gilberto and Angel can have a point. They're correct. So they told me negative 3, 0, and 3. And that's great. But sadly, that's not even the complete list this time. Why do I think there should be more answers this time? Yes. And you can have 2 points for that. What degree is this? What degree is this problem? No, Jax and Gilberto. They really said the same thing. Sorry. Words, English, fun times. What is the degree on number 3? Yeah, it's 5. So we should have a list of 5 things. And right now I see 1, 2, 3 things. So we're not done. So while we might have finished and saved the day on number 1 by just only using our calculator, we can't save the day on number 3 without factoring. We would have to factor on a problem like number 3. Before I go crazy and start using synthetic division and all that jazz, I am a smart girl. There is something I can do first on number 3 before I do anything else. What can I do on number 3 if I'm factoring? Take out an x. Get a... wait for that, ma'am. Okay, well, if I set this equal to 0 right now, I already see where x equals 0 came from. I got that. Okay, you just took a test on how to deal with ones that were to the fourth. When they're to the fourth and they look like this, what are you supposed to do so you can figure out how to factor them? You had 2 on your last test. Yes. And then so this becomes y squared minus 8y minus 9. And can we factor that? And you can have another point page. So I've got y and y. I need my factors to add to negative 8 and multiply to negative 9. Negative 9 and positive 1. Page again, get a point. Negative 9 plus 1 is negative 8. Negative 9 times 1 is negative 9. That's perfect. But Paige, alas, is not done. What does she need to do from here? She's got to go back to x squared. So it's going to be x squared minus 9. X squared plus 1. And, of course, that x at the beginning, that I'm just going to bring him down. I kind of ignored him the whole time. Okay, so I get where we got the 0 from. Heck, now I just got to consider the other two, and they're pretty straightforward as well. If I set x squared minus 9 equal to 0, I get x squared equals 9. So, of course, I get x equals plus or minus 3. So I can see where the negative 3 and the positive 3 came from. They came from this one. But what do I do? What are my answers for the other one? Say it again. No. Yes, and you're just going to put plus or minus I because you're smart. If we put one I in front, we look like we kind of lost our mind. So we had x squared plus 1 equals 0, so x squared equals negative 1. So x equals plus or minus the square root of negative 1, which you know is I. So x equals plus or minus I. So finally, I have 5 answers. Negative 3, 0, 3, positive I, negative I. So I'm finally done. It was degree 5. I have 5 things listed. Yay, good for me. Okay, so let's not be mad at number 2 anymore. Let's go back to for number 2. Let's graph number 2 and see what happens. So y equals, it's x to the 4th plus 6x to the 3rd plus 73x squared plus 384x plus 576. I graph it. And I know it's going to be a W because it's a 4th degree and it's got that leading coefficient of 1. And yet for some reason it's not all shown up here. What a sad day on that. And then sadly, this is where life gets annoying. This right here. So what's the 1, 0 we see? Okay. And then somebody be smart and tell me something I should notice about that negative 3 before I go working all the math. What you just tested on about how to draw and sketch graph. Look at that graph. What's special about that negative 3? It bounces there. So what does that mean? It has a multiplicity of at least an even. So probably 2, if not 4. So yeah, that's something we need to notice. So I'm pretty positive that my list down here is only going to have 3 things because one of them is going to be negative 3. But since it has a multiplicity of 2, it's showing up twice on my list. So I only need 2 other things. And again, did you have to realize all that? No. But why did we? I mean, like, we just tested all that, so that's a useful thing to notice. So I'm assuming when I factor x plus 3 squared is something that I could factor out, just FYI. Now I'm a one step at a time. I assume I'm going to get to this, but oh god, I don't want to have to. You really want to have to do x squared plus 6x plus 9 and use long division? I don't. I'm going to be lazy. I'm just going to do the 1, -3, use synthetic. Because I thought maybe I could do grouping or something fun before I jump straight to synthetic. But no, because this one is ugly and ugh. So 1, 6, 73. 384, 576. I bring down my 1. 1 times -3, -3. 6 minus 3, 3. 3 times -3, -9. 73 minus 9, 64. 64 times -3, say it again, ma'am. -192. 384 minus 192. I also got 192, which is scary, but 192 times -3, -576. Again, everything has worked out well because I knew this was a factor and I got a remainder of 0. If I hadn't gotten a 0, I've messed up synthetic. I need to raise my hand. I swear Compton will help me fix it. Okay, so for sure I know it's x plus 3. And then I was degree 4, so I'm starting off degree 3. I've got x to the third plus 3x squared plus 64x plus 192. And I'm not going to lie, the first time I saw that bad boy, I thought, Lord Jesus, what am I supposed to do from here? But I'm not using my brain. That's why we just took a test on stuff like this. How many terms are there? There are 4 terms. We're going to do grouping. Whoever said grouping, you can have 2 points. So I'm going to put these in groups. What can I factor out of that first group? If you factor out an x squared, you're left with an x plus 3. What can you factor out of that second group? Well, you're hoping to end up with just an x plus 3, right? So you're praying 64 comes out. And so 64 times 3 is 192. She's right. That 64 comes out. So I've still got my original x plus 3. What are my other 2 things? X squared plus 64 and x plus 3. Okay, well then no duh. If we go back and set all these equal to 0, clearly we're going to get x equals -3 twice, hence that multiplicity of 2. So I know what this one leaves me, I know what this one leaves me. What answer should I get from the x squared plus 64? Do I get -8? I'm going to plus or minus 8i. Because I'm going to end up taking the square root of a -64, and it's going to end up being plus or minus 8i. Okay, again, nothing that radical. We're really just combining all the other junk we've done in Chapter 5. But if you've not been paying any attention in Chapter 5, Lord Jesus, bless your heart for Friday, because it's coming.